Alright, so I want to solve the logarithmic equation, and easiest way, condense it back into one single logarithm, if at all possible. So on the left-hand side, I have two logarithms being added together. Do they have the same base? Yes. What is that base? It is a base of 10, right? So they do have the same base, so I can use the product property. If I'm adding on the outside, I can rewrite this as multiplication on the inside. So I get log of 5x times x minus 1 is equal to 2. And now that I have a single logarithm on the left, or whatever side, and a plain number on the other side, I can kind of just use our exponential property, rewriting this as an exponential. So my base to the power of 2 is equal to this whole mess over here. So I end up that 5x times x minus 1 is equal to 10 to the power of 2. And it looks ugly, but now it's just a regular old equation. Let's see what happens. So to solve this, I'm going to distribute my 5x. So I get 5x squared minus 5x is equal to 100. And I want to make this as simple as possible. What do you notice about all three terms that I have? What do they have in common? A 5. I'm going to just go ahead. I'm going to divide everything by 5. Boop. So I get x squared minus x is equal to 20. And now this is a nice little quadratic. So whichever way you choose to solve the quadratic, either way it does need to be set equal to 0. So I have x squared minus x minus 20 equals 0. You can solve this by quadratic formula, by factoring, completing the square if you want to be super fancy. But this does factor nicely into x minus 5 and x plus 4 equals to 0. So I get x minus 5 equals to 0 and x plus 4 equals 0. So x equals positive 5 and x equals negative 4. Alright, so I end up with two solutions, and it's very possible that they are both solutions, but I need to check. I need to plug each solution back in and make sure that it gives me a positive number still in my argument. So I have log base 10, log of 5 of x, plus log of x minus 1 equals 2. And I'm going to plug in each one of my possible solutions and make sure that I get a positive value still in my argument. So if I plug in positive 5, I get log of 25 plus log 5 minus 1 gives me 4. That's definitely doable, right? They're both positive, so 5 checks out. Definitely a solution. Now likewise with negative 4, if I plug in negative 4, I'm going to get log of 5 times negative 4, which already off to a bad start, gives me negative 20, plus log of negative 4 minus 1 gives me negative 5. I cannot have negatives inside of my argument. It doesn't matter that the solution itself was negative. It gave me a negative value inside my argument for the logarithm. So negative 4 is not a solution. And if you recall, this is an extraneous solution, right? So we have to remember to check for that. This is an extraneous solution, so my only solution is x equals 5.